Mars, the red planet. For centuries, it has captured humanity's imagination, a mysterious world, distant and alien, yet so tantalizingly close. A neighboring planet that might one day become a new home for humankind. The idea of colonizing Mars has long been the stuff of science fiction, but today, it's quickly evolving into a reality. The dream of building a city on Mars has moved from the realm of possibility to the forefront of technological ambition. But this isn't just about sending a handful of astronauts on a one-way mission. It's about creating a thriving, sustainable colony where humans can live, work, and build a future beyond Earth. But how do you design such a city? On a planet where the landscape is barren, the atmosphere inhospitable, and the weather unforgiving. How do you create homes, schools, parks, and workplaces on a world with no breathable air, extreme temperatures, and constant radiation? Today, we delve into the architecture of the future, the design principles and cutting-edge technologies that could one day shape the first city on Mars, and the challenges that come with turning this dream into a reality. To understand what it will take to build a city on Mars, we must first face the formidable challenges of living on a foreign planet. The Martian environment is harsh and unforgiving, requiring every structure to be carefully designed and meticulously engineered to withstand conditions that are alien to us. Let's begin with the air, or rather, the lack of it. Mars has almost no breathable atmosphere. In fact, 95% of the air is carbon dioxide, with just traces of oxygen. Without a way to provide a livable atmosphere inside the city, no one could survive. The challenge? Designing sealed habitats that allow humans to breathe and thrive, while simultaneously shielding them from the planet's frigid temperatures and deadly radiation. Radiation. Mars offers no natural protection against it. Unlike Earth, which has a magnetic field and thick atmosphere that deflects harmful cosmic rays and solar radiation, Mars offers no such defense. This is a silent, invisible enemy that can cause harm over time, potentially leading to cancer or other diseases. Architects and engineers will need to find ways to shield people from radiation. One idea? Using Martian regolith, soil from the surface, to cover habitats, effectively turning the ground into a protective shell. Speaking of temperature, Mars is cold, really cold. The average temperature is about -60 degrees Celsius, with extreme lows of -125 degrees Celsius at night. This means that any city built on Mars needs to be insulated, capable of maintaining a warm, stable environment inside. The structures themselves will need to be airtight and designed to trap heat, making efficient use of energy in an environment where resources are limited. These are just a few of the challenges that lie ahead. But the beauty of space exploration is that it pushes us to think bigger, to innovate in ways we never thought possible. And that's exactly what's happening as we prepare to build a city on Mars. Innovation, imagination, and determination are working together to overcome every obstacle. So, what will the actual buildings on Mars look like? When you envision a city on another planet, the designs must be radically different from anything we've seen here on Earth. Yet, there will be echoes of home in the designs, because at the core, we want Mars to feel like a place where human life can flourish. Let's begin with the habitat, the first and most critical part of the city. Early designs focus on inflatable modules, large, pressurized, flexible structures that can be shipped to Mars and deployed on-site. These inflatable habitats, made from advanced materials, can be quickly inflated to provide a large, livable space. They're strong, resilient, and capable of withstanding the vacuum of space and the pressure inside. Once deployed, These modules will be covered with layers of Martian soil to shield them from radiation and offer additional insulation against the extreme cold. But inflatable habitats are only one part of the solution. Given the need for long-term sustainability, another design concept involves building directly into the Martian surface, excavating into the ground to create underground habitats. Why underground? The Martian soil, or regolith, offers natural radiation protection, and temperatures below the surface remain relatively stable, avoiding the wide swings of hot and cold that the planet's surface endures. Some researchers even suggest using natural Martian lava tubes, cavernous tunnels left behind by ancient volcanic activity, as perfect structures for future cities. Whatever the design, one thing is certain: these habitats must be self-sustaining. In a world where resupply missions from Earth will be costly and infrequent, everything the city needs to survive, from oxygen to food to water, must be sourced locally or recycled indefinitely. Future architects will need to design buildings that integrate farming systems, water purification, and even waste recycling, creating a closed-loop system where nothing is wasted. The key to life on Mars is sustainability. In this new world, every resource must be carefully managed, and energy generation will be a major part of this balance. Mars may be cold, but it's rich in sunlight. With long, clear days and abundant solar energy, the Martian landscape is perfect for solar power. Solar panels will be the primary source of energy, though they'll need to be highly efficient to compensate for the dust storms that can block sunlight for days or weeks at a time. But solar power alone won't be enough. To ensure a reliable power supply even when the sun isn't shining, backup energy systems will be essential. Nuclear power, particularly small modular reactors, is one solution that's being explored. These reactors are compact and efficient, capable of providing a steady, consistent supply of energy to the city, even during the long Martian nights. And it's not just energy that needs to be managed. Water is a precious resource on Mars. Engineers are already developing systems to extract water from the Martian atmosphere and from ice reserves below the surface. Once water is collected, it will be purified and reused, creating a sustainable water cycle that can support a growing population. Sustainability will be the backbone of Mars City. From energy and water systems to food production and waste management, everything will need to work in harmony, ensuring that life on Mars is as self-sufficient and resilient as possible. But building a city on Mars is not just about surviving. It's about thriving. Human beings are social creatures. We need more than just shelter. We need spaces to connect, to collaborate, to rest, and to recreate. And that's where the architecture of Mars City becomes something truly unique. Imagine parks beneath domes of transparent materials that allow you to gaze out at the Martian landscape. Shared spaces where astronauts and settlers can unwind, exercise, and interact with one another. These spaces will be crucial for mental and emotional health, offering a semblance of normal life in a setting that's anything but ordinary. Community hubs will be designed with the same sense of warmth and comfort we find in our cities on Earth. Libraries, cafes, and communal kitchens could provide a sense of familiarity, a connection to home. These spaces will be essential for building camaraderie, fostering creativity, and encouraging the teamwork needed to build a sustainable society on Mars. Every aspect of the city will be designed with one thing in mind: making life on Mars as Earth-like as possible. The architecture won't just serve functional purposes, it will help build a sense of community, offering the social and emotional support needed to make the city not just a place to live, but a place to belong. In the end, Mars City will be a self-sustaining ecosystem, with every building, every system, working together in harmony. It's a vision of the future where technology, sustainability, and design converge to create something entirely new. Something that allows humanity to expand its reach beyond Earth and set up shop on another world.